Hello everyone, thanks for coming. My name is Jason Dodge from Lane Education Service District. I manage firewalls for a lot of the school districts and do web filtering and such. As we know, social media is needed a lot today to do a lot of marketing for school districts, and it's obviously an attack vector for malware and such. So got a great presentation today from Zach Forsyth on social media, the malware gateway. He's a security analyst or architect from Juniper.
Thank you. Give me this creepy thing which makes the camera follow me around. Which I'm sure is really secure, right? Yeah, it makes me feel good. So welcome everyone. I know it's standing room only. I promise to try to keep this interesting. Let me start out. I'll tell you about my accent, because the problem is that in the first 2 minutes, no one listens to anything I say. They're just trying to work out where I'm from.
New Jersey.
No. This is a Californian accent. Not true. I live in California, but my accent is mostly Australian. There's a little bit of English, South African, New Zealand, because I've lived in all those places, and now a little bit of American, because I've lived here for about 8 years. So I work for Juniper. I'm an architect. I don't usually dress up like this, but I'm a speaker today. I wear a hoodie a lot of the time. I used to like hacking into things a lot. I tend to not do that anymore. It's not like sort of career limiting to do that for your whole life. When you're in your early 20s, it's really fun. So I'm just going to talk about social media, lots of different attack vectors in social media, and I promise there's only like 2 or 3 slides that actually have any product stuff at all. Right? It doesn't even say the word Juniper on it, I don't think. So let me kick you off. Oh, that slide isn't supposed to be in there. Oh, yeah, it is. Who here thinks they can be totally secure? Or who here thinks they have built a totally secure network?
Wrong.
I like it. Usually someone says an air gap is totally secure. But that's actually been proven false too. There's some really clever researchers, mostly from Israel, who've done a lot of work on breaking air gaps and working out how to transmit information between 2 computers that aren't networked, using a microphone on one, using the fans on another one, really low bit rate, right? It just shows ingenuity and creativity. So I'll start with a cliche. This is my favorite cliche. A defender has to be flawless every single time. An attacker only has to succeed once, right? And this is a really important thing to keep in mind when you're thinking about security. And my dad's pretty smart. He's a dentist, but he lives in Australia in the countryside. And I had to explain like what my job was to him a few years ago. And I tried to explain it in the normal terms, you know, talking about technology and firewalls and all this stuff. And, you know, his eyes glazed over in 10 seconds, right? Because he's not a technology person. He can use an iPad just, right? He can send a text message. He's pretty proud of that.
Nothing wrong with iPad.
So this is how I explained it to him. Does anyone know what this is from? Which movie?
Ocean's 11.
Ocean's 11. Isn't it a good movie?
It's a great movie.
I love it. This is how I explained security to my dad. I said to him, do you know the movie Ocean's 11? And he sort of said, yeah, he's seen it. He'd seen the original, right? 1960s. But I explained it to him and I said, look, think about it this way. You are the casino, right? And he's like, yep. And I said, you've got a lot of money. It's all in a vault. You know, it's underground. It's protected by security guards, cameras, all sorts of technology, lasers. Like, just think of all the things that you could possibly like pile on top to try to secure that. I said, the fundamental problem is you're defending it against Brad Pitt, George Clooney, right? Julia Roberts in the later ones, right? All your adversaries are really creative, really smart, and the worst one of all is this guy. Does anyone remember who that guy was? He's that dude that pops out of the box, right? He's the guy that gets past your like last line of defense. And when I put it in those terms, my dad sort of understood it, right? He's like, yeah, I'm the casino, right? This is a really hard problem. And then the other example I gave him was like, think of the simplest thing you could try to secure, and it's a safe, right? Just a steel safe that you put things in, right? Forget about all the complexities of cloud and mobile devices and social media and all the problems you have as a technology sort of company and a landscape, and just think about this simple steel box that you're supposed to make secure. I don't think there is one that is secure, you know? Like a human with enough time and energy and effort can break into a steel box. So if we can't make a steel box secure, how do we make this really complex IT landscape secure? All right? My dad was like, yeah, all right, I get it now. So then he sort of like, now he explains that to his friends, and I'm sure it's like Chinese whispers and it comes out totally differently, right? He works on the set of Ocean's 11 or something. But if we look at this as a technology problem, it looks a bit like this, right? You guys didn't know that I broke into all your networks when you came here and I stole your network design. All right, this is it. All right, this is pretty much what everyone's built over the last 5 or 10 years. We have the internet way over here. A lot of the time now we see people running double stack of firewalls at the perimeter, right? Just to get some differences in performance and differences in capabilities. So Palo Alto or Juniper would be a layer 7 firewall. Cisco or something different might be lower down. But you aggregate all your log files to something like Splunk. You have load balancers sitting in the middle. You have maybe Radware boxes doing SSL inspection. You have something like Proofpoint, right, doing your email inspection. Then you tend to have DLP. You have something like FireEye if you've got the budget for doing something like advanced sandboxing. You have Blue Coat for web filtering. You have some aggregation firewalls. You hopefully have some VLANs with some separation, but it seems these days people love building big flat networks where everything's accessible. And then on the endpoint, you'd have something like Sophos or a traditional antivirus, and then maybe Cylance, CrowdStrike, something that you would class as next-gen AV. Right? So we have all these products. And sometimes someone puts their hand up and says, actually, I have every one of those products. And usually people have more. There's other products I haven't put on there. These are like the main ones, the heavy hitters. And this, in totality, may equal 100% security on some days, may not. Right? Do you even know that they're all configured to be, their optimal selves all the time? Like, I'm a pretty smart guy, I think, and I couldn't put my hand on my heart and say I could administrate all these boxes, make sure they're configured perfectly, and often you only have a team of 2 or 3 people or one person that's supposed to make this perfect. Right? We're looking for this flawless defense. Right? It doesn't really equal that. So a lot of people think their security gets better every time they add a new product. So you go to RSA, you go to Black Hat, you come somewhere like this, some guy stands up in front of you, he's from the latest Silicon Valley startup, and he's like, I got the silver bullet for you. All right, whatever it is. And they add it into their network thinking that they're 100% secure. Really, security looks a bit more like that. All right? If you had everything working perfectly in your favor, you'd be 100%. Right? But you have these dips all the time. Just say this is a month, right? And you'd have a dip where you come down to 88% effective, and you're back to 100 for a little bit. So you're never going to reach that flat line of 100%. I don't think you ever can, unless you have a very, very simplistic network. But the problem is you have end users, right? And they mess this whole thing up. So this isn't totally relevant to your guys' industry, but there's a really interesting portal that you can go and log into. Anyone can do this. It's open to the public. The Department of Health and Human Services, all the health industries in America have to report to these guys and tell them when there's been a breach, right? Just before I came on this talk, I loaded it up and I can see 420, 419, 418. So these are just the last few days, right? So there's breaches of all these different companies. It tells you what sort of breach. Could be a hacking incident, could be the theft of a laptop, could be they lost their backup tapes. Gives you a little bit of detail, it doesn't give you a lot. But it does show you how many individual records could be affected. Some of them are huge too. Often there's ones that pop up, it's like 2 million, 3 million, 200 million. Right? It's interesting to me to think about these companies. And if you compare them, not as your direct peers in your industry, but also as companies that bought that big stack of products, has the same size security team as you. Right? They don't have different technology. They probably have the same, some better, some worse. They have the same sort of team. They have the same sort of industry compliance that you have to reach, right? Everyone's trying to build a really good, solid network with incident response plans and things like that. And yet, when you look at these really public records, you can see people getting breached hard. I pulled some of the stats. So this was last year. So in July, they lost nearly 2.5 million health records. August a bit less. November's pretty bad, nearly 3 million, over 3 million health records. So it's sort of funny that they can't secure their data, right? And some of them have bigger budgets, like I said, than maybe you have. And the reason is you're sort of on this playing field where the attackers are really creative. They have unlimited time, pretty much unlimited resources. They use the cloud. They have teams of people. They offer incentives, employment plans, time off, all those things. They operate as businesses because it's money to them. So when you start to look at like how many URLs does my web filter, my firewall, my anti-spam filter have to keep up with, right, to stop my users clicking on stuff. The numbers are pretty crazy. This is from McAfee. But you can see it's always like millions of new URLs every single month. And often now an attacker will send an email to a company and every single URL will be different in every email. So each person in this room would get a unique URL. So your defense has to try to like cope with all these brand new URLs. And if you look at like our first line of defense, pretty much all of the products that you guys use or that we all use rely on antivirus, right? That's like our sort of our mainstay of all our products. Like a web filter uses antivirus, a firewall does, a cloud sandbox does, email filter, and endpoint protection on the user's desktop, etc. All uses antivirus. And the thing for me with antivirus is all these products, they're very familiar to you. Most of them are really familiar to you because they've been around 25 years, roughly. McAfee way back was the good firewall until John went crazy, sold it off. He's a very interesting person. But all these guys have had the longest runway in security to perfect their products. All right, so I would expect to see them all being either 100% effective or just under 100%. But it's interesting when you start to break down the numbers. This is just from 1 month, one test, sorry. This is from AV Comparatives. They ran like 1,100 malware samples through all these different products. And you can see a couple of them are 100% effective. McAfee's one, Bitdefender, and Trend Micro in the end. So just in that snapshot of time, they were 100% effective. So that's great. But if you break it down a bit more and you look at the ones that aren't 100% effective, even if you're only, say, 99.8%, 0.7% effective, which is what I would reasonably expect most products to be if I'm having a great day, out of just over 1,000 malware samples, I'm still running 4, 5, a handful of samples, right? And when I think about that, I think, how long would it take the end users on your network to run 1,000 pieces of malware or click on 1,000 new URLs? For some companies, this is just their morning or a couple of hours on a Tuesday when everyone comes in. For some companies, it's a couple of weeks. But people are going to click on 1,000 new URLs, or they're going to run 1,000 attachments out of emails. So it just becomes a numbers game, right, when you think about it. And even if you have something like a sandbox, everyone makes them now, FireEye has one, Juniper has one, Palo Alto, whoever. Most people configure their sandbox to say, when an email comes in, for instance, they'll take the file and they'll put it in the sandbox, but they'll still deliver that file to the end user. Email was a bad example, actually. Web is a better example. If they click on a link, we give them the file. Does anyone here have their sandbox configured in a way that it actually blocks access to the file until you have a verdict? See, not a single hand went up. Right, that's a secure way to do it, in a way. But no one does. Everyone's sandbox just lets things through. So it was that silver bullet that never quite worked out.
She asked how many people have a sandbox.
That's true. Everyone should have one. There's open source ones, they're free. But yeah, sandboxes are actually coming very commodity. Now, you can get them for free in some antivirus products even. It was touted as like the best way to do security, but it actually doesn't quite work out when you look at the mechanics. So it's interesting if you look at emails and then look at some of the data. So 40% of companies say they've been a victim of a social media spear phishing attack. I'll give you some examples and show you why. It's about 1 in 100 emails is malicious, roughly. That's going to change depending on industry and things like that. So the reason social media is such a rich hunting ground is because each of these platforms has really sort of deep, meaningful information about your employees, about your board of directors, about your investors, things like that. If you think about it, it's not just LinkedIn that's your number one social media platform, right? There's the other ones, LinkedIn. I'd even call something like GitHub a social media platform, right? If you've got guys coding, they're on there sharing comments with each other, sharing code. It's a way they interact with other coders. So an attack looks really simple on the surface, right? Basically, usually using phishing is the usual way, but it could be a LinkedIn message, could be a Facebook message, could be a GitHub comment, could be anything. We basically just deliver a document, an Excel file, something. Like let's call it some sort of transport mechanism and I'm just enticing you to click on that link. Usually it runs, there's a flaw in the product, something like PowerShell runs. This is actually the really important bit where we download the payload. I almost don't consider the very first like PDF or the document that you click on to be malicious, because all it's really doing is just, it's a transport mechanism for the actual payload. So it'll deliver an executable to you, and then usually once that executable runs, we end up with command and control traffic. And by the time you're looking just at command and control, it's really hard to detect on the network. I'll show you some examples of that in a minute. And the reason why a social media attack is particularly effective, the top one here, it's a bit of a busy slide, but this is a traditional attack, right? Step one, someone does things like ping all the devices, do port scans across the network, try to work out the footprint of all the devices they can attack. That's pretty noisy, right? And usually if you have some good security tools, you can catch them very, very, very early on in the attack sort of life cycle. But a social media attack, what they'll do is they'll set up fake accounts, they'll create connections to people, they'll impersonate the CEO, etc., things like that. And they basically win trust of the users until they get to a point where they want to execute the attack, but it's way down in the attack chain, so it's a lot harder to detect. Sort of looks like this. So they're going to establish a legitimate looking account. They're going to try to get someone to trust that account in the organization. Then they're going to maybe create multiple accounts, link them together, create domains. And there's some good examples where it's taken someone like a year or more to actually just set the groundwork to then apply an attack to an organization. Then they're going to send URLs to people. They click on the URLs and they get their reward. So I'm going to give you an example now of a really malicious attack. This is one that a lot of people fall for.
No.
That's it. That's a social media attack. And the reason is because everyone likes cheap Ray-Bans, right? $25 Ray-Bans, I click on that. A lot of users will. So it's actually surprising when you think about 1 in 100 emails being a phish. You could think about it the same way in social media. But essentially all that the attacker's doing is looking for a way they can convince their audience to click on the link. And the more you know about someone, the easier it is. Like maybe you don't like Ray-Bans, maybe you love golf, maybe you love alcohol, maybe you love hang gliding, I don't know what it is. But I can send you an email or send you a message or get some sort of link to you that actually makes you click on it. And one of the best ones is when they send an email, and the attackers don't do it that much, but the email just has something like an Excel attachment that says your company name dash salary report, right? And everyone wants to see what their peers make, right? That's one of the best ones that people click on because they want to see who's making more money than them, they want to go ask for a raise, etc. So it's really just looking for a way to motivate you to click on something. All right, here's another one. All right. People are going to send this to you today, tomorrow, next week. You're going to see a bunch of these from this guy, from someone else over here, because you met him at the bar or whatever. But this could just be the actual opportunity the attacker's taking, that they know there was a conference that was on, they set up a fake account, they then reach out to every person they can think of to actually try to connect with them. And the beginning of the attack may not be malicious at all. It could just be that one connection they want, because they want to establish that chain of trust where someone looks at their profile and it looks like they should trust that person. So a few examples from things like Facebook. So this is actually 2 different accounts. One of them's a fake account, one of them isn't. This one's, they're actually just using the background image to create the verified by Facebook seal. And a lot of the social media platforms now put these seals on there to try to tell you that this is the legitimate account for that entity. But they just put it in the background image. Same for Starbucks, except this time what they did was they used the Cyrillic alphabet from the Russian language to put what looks like an S on the screen, but it's actually not an S. If you saw it on a Russian computer, it would be that weird looking one. So they basically set up accounts to, like people love Starbucks, people love Ray-Bans, and they want these accounts so that you will click on them and trust that link just enough to do that one click, really. Then they're looking to exploit you after that. Here's another one. This is just a Facebook message saying, hey, check out this photo. Or here's another one saying, do you want a gift card at Walmart? And what's interesting with this one is that there's no links in that email at all, right? So your defensive technology that you have implemented doesn't trigger here because they're telling you to go to Google and type in a keyword and then do a Google search and then click on some subsequent links because they've actually set it up in Google so they're the top of the results for those words. So I guess what I'm getting at, a lot of it is just attackers are really ingenious. And I've got in trouble for my last slide because it actually was Britney Spears in a swimsuit. I blurted it out though. But what they were doing was using the comments in a public person's profile to send command and control data to something that's been compromised. So compromised computers were reaching out to Facebook, going to this picture itself, trawling the comments until they found ones from this A. Smith 2155, and then they would look at the actual contents of the comments and then take action inside the network based on those comments. So I'm curious, like as a security administrator, if I'm looking at my logs, I'm looking at my firewall, all my fancy sort of technologies that I've implemented in my network, how do I find that? Like how does that pop up in my feed? Like maybe it does if I have, like all of a sudden I have high numbers of users all going to Britney Spears' profile. I might think that's a bit weird, but it'd have to be something like quite a large anomaly for that to happen. So here's an example of a really poor fake account. So this is a LinkedIn account. They've given her a name, a pretty picture, and she's got a little bit of background and some skills. None of us would probably fall for that. Although interestingly, she has over 500 connections. But here's a better one. This lady's famous, she's not real. This is Dr. Emily. This is a fake account that was used in an attack against a particular organization. But if you looked at her LinkedIn account, you'd see that she has some background summary, she has work experience, she even has a research paper published, and there were multiple papers published by this fake entity as well. Right? So they're just establishing trust with you. And most users would look at this and say, especially if it was directly related to your field, say, I'll connect. Right? Sounds good. This is another famous one, Mia Ash. This is mostly on Facebook, LinkedIn, but there was a whole chain of events behind this one where they set up these fake profiles, they set up fake websites as well. So essentially from March in 2016 until February in 2017 is the timeline for that attack. So essentially what they did was they set up a site on a blogging website initially, then they registered a domain for this user called Mia Ash. Then a different victim actually posted on her Facebook account and made some comments on a photo, and people don't know whether it was a real victim or not. Then another domain got registered, and then victim B was actually convinced because victim A had already been talking to this person. They both ended up getting exploited, but there was this chain of trust because it was like someone they knew had already talked to them and established a communication with them, basically. But it sort of shows you the lengths that an attacker will go to on a social media attack and how long that is. And really, like I said, you don't get the opportunity to detect this attack until the very end, right? At the end of a year, after that attack has been establishing trust, building accounts, building domain names. They even do things like send physical posts through the mail, things like that, like send a brochure that makes it look more legitimate. Here's an interesting picture. I don't know if people remember this from a few years ago from the Oscars. It's a selfie. But the interesting thing about this, I've got all these numbers around these people. Does anyone have a guess what those numbers mean?
Number of followers.
Maybe in millions.
Impersonation.
Yes. The numbers mean how many impersonation accounts does each of those users have. And the interesting thing is that Brad Pitt is very enterprise heavy. He has 11 fake LinkedIn accounts. Right? But it shows you that you have all these fake accounts on all the different platforms, and you'd expect Facebook, Twitter, etc., Instagram, but would you expect them to have fake LinkedIn accounts? It's probably more than that now too, because this is from a few years ago. But it's interesting to think that like you see that selfie on any one of these social media platforms, you click on it, you end up on an impersonator's account, and then you end up following that link to wherever because they're just saying, hey, check out this new book that Oprah wrote or whatever it might be. And you end up going to this fake account and getting compromised. Here's another couple examples. This is just someone just posting a thing saying, you should go check out this document. That one's pretty easy to notice. Here's this poor guy called Craig who actually reaches out to an account called NatWest Help. It's a bit hard to read this. But essentially he writes to them, how long does it take to get a new bank card? Mine's expired. And this fake BankWest account starts responding and saying, yeah, we can send you a new card. Tell me what your details are. Tell me your social security number. Or go click on this link and fill out the form that basically just, they give up all their information essentially. I can't remember why I had that one on there, so we'll skip it. It's been a while since I did this deck. This is a really interesting one. It's called Hammer Toss. I really like this one. So basically it was a backdoor into corporate networks where once the machine was compromised, it would reach out to a Twitter handle every single day. It would be a unique Twitter handle too. So it would go out to something like this. I don't know if you can see it. It's 234 Bob 234. Every single day the handle would change to a different one. And they had all these accounts set up in advance. When it reaches out to the Twitter account, it basically looks for a tweet with a URL and a hashtag, and all it's doing is just giving them a link to where there's an image hosted. And in this instance, that image was hosted, I think, on PhotoBucket. But there's been other instances where they were hosted on, it was like a Craigslist ad. And the photos in the Craigslist ad are the ones that it would reference. Right? Anywhere you can post an image. So then it would go grab the image, and it would then use steganography to decrypt what was in the image to then give it instructions to do things on your network. Right? Really hard to detect this when you think about the chain of events and all the different technologies you have in your network to try to stop that. Pretty much everyone allows Twitter, some people don't. But even if you did, there's no reason you couldn't just post up something like this that uses Craigslist, or it uses eBay, or it uses GitHub, or it uses LinkedIn, or it's just endless really. Right? I can just host stuff on OneDrive. I can host stuff on, you're going to use one of the sort of the cloud drives. Everyone is. And there was another one of these that was similar where it would actually pull down an image and it would just use what's called the EXIF data out of the image to then take commands. And the EXIF data just stores things like what aperture the camera was set at, what frame rate, what GPS coordinates, what sort of camera it was, the date, time, etc. But they would use the details there to actually send commands to a computer inside a network. So here's an example using Twitter. This one's a little bit hard to read. But essentially the malware would reach out to the Twitter account called Illusion. It has leet speak, that's how you know it's bad. It's very important. And all it was doing was, and it was pretty simplistic, it was just looking for tweets that had words like wake up, target, stop, de-execute, things like that. And there's no reason this person couldn't have gone that extra step and said, you know what, if my my tweet has the word oranges, it's going to mean wake up. Or whatever, you can just have code. They didn't even try to hide their code. And it's interesting to even look at platforms that aren't just like a pure social media platform, but something that's more like a work platform. So this is GitHub. What happened was someone would go and look at your GitHub repo. They'd end up sending you this email and say, hey, I'm really interested in getting a job at your company. Here's my resume. I've been through your GitHub. I like your code. This project looks cool. I've got skills in that area. I'd love a job with your company. Click on my resume. Right, that's pretty compelling to most people to actually do that. And then when they clicked on the resume, of course, there was some exploit in Word where it would load up some PowerShell and it would then download an exploit. All right, my next slide is where I actually take a drink of water because it's a challenge slide. It's to see if anyone can look at this slide and think of yourself as a security operator looking at your logs, looking at your SIM or whatever your fancy technology is that's giving you this data. Tell me if there's anything wrong with it.
Looks like it's, you can't see very well from here, but it looks like it's extracting a zip file for sure.
It is. I can tell you in 3 or 4 years, no one's ever told me what's wrong with this. So you don't have to feel bad. And it's pretty obscure. But you're right, a lot of people say, hey, it's in the Russian language. Yeah, it's also doing some gzip functionality.
Really ugly font.
It's an ugly font, but this is what real security people look at every day. This is like the Matrix to us.
Oh, but there's also like that proxy connection keep alive down there.
Yeah, or the max
It
age.
doesn't look healthy to me at all.
Yeah,
And the fact that it's embedded in an image. And
I know.
everything down there.
there's a few flags here. The thing I want you to keep in mind is I've just started to see a whole ton of these pop up in my security logs. I don't know why, but the weird thing is this looks legitimate, right? Toolbar queries.google. Well, for one, you should notice it's not HTTPS. That'd be a flag because Google moved to HTTPS a while ago on everything. But the actual real flag is that this domain used to be used by Google in 2003 and it's not used anymore. It's been shelved a long time ago. That whole project, these toolbar queries thing, got shelved as a project like 10 years ago. And the interesting thing was what the attackers were really doing here is they were just basically getting a piece of malware onto the device. Then they were sending DNS requests to their own DNS server. Right? And if your firewall allowed DNS requests outside of your network, or you did forwarding from your own internal DNS server, if you didn't know the domain, you would forward it to their DNS server. It would reply back with toolbarqueries.google.com is 176.9.81.4, and then it would just send those data, send the images to that server. Right? And there's some really common attacks that use DNS tunneling in the same way to pass information back and forth using like DNS text records, things like that. DNS is actually pretty scary from a defense point of view. But it seems pretty simple, right? They're just sending data to this domain. Unless you suddenly got millions of these in your logs, as a security administrator, you would never red flag that. Right? So here's another example. This is the photo bucket one, actually. So yeah, the exploit basically reaches out to PhotoBucket, looks at the EXIF data in the actual image itself. So all the malware is doing is just reaching out and just grabbing images once a day. It goes and grabs a JPEG, or it grabs a GIF, or a PNG file. But when it gets the PNG or whatever down onto the system itself, it looks at this EXIF data, it pulls out an IP address based on, say, the GPS coordinates in the EXIF data, and then it sets up, a command and control stream to that server. Maybe you'll catch the command and control stream, but those can be very quiet as well. All right, ransomware. This is one of my favorite topics. So ransomware was really huge. This is actually real ransomware here too. My machine's been taken over. I know I'm good. This is the Bad Rabbit ransomware. It looks pretty to put on a slide. But I don't know if you noticed, but ransomware was really huge. 2017, 2018, but recently it's really died off. You might be thinking, where's all the ransomware gone? Right, it was a really interesting area to actually research and stay on top of, because I'd like to say that all the ransomware authors were sharing data with each other. They were really innovating. They were pushing the boundaries of how to get malware onto systems, how to get past all the different defenses, etc. And I'll show you why. This is sort of the ancestry or the family tree of ransomware that ACPEnw put together. So we first saw ransomware back in 2011. We started to see more and more prevalence up until 2015, and I'm just hitting 2016. That's just 2016. There's no slides that exist for 2017 onwards because it just explodes exponentially. And I can't make a slide. It's too much of an eye chart. But when you think about your adversary, right? Think about the attacker. You can almost think of these like different libraries and different tools that they can use to attack your network. Because they don't reinvent the wheel. They share code and they'll look at another piece of ransomware and decide the way they're like popping root on something is like really interesting and an easy way to do it. But if you think about your adversaries having diversity and there's lots of them, etc., ransomware is a good spot to look at. But let me point out why ransomware died off. So this is towards the end of 2018. You can see pretty much Q4 2017 was ransomware's like heyday. Right? That's when everyone was getting exploited. It started to drop off a lot, and the reason it did is because something came along called coin mining. I don't know if any of you guys got hit by that. But essentially the attackers worked out ransomware was making them some money, but there was a lot of new defenses that came out to stop ransomware. All of a sudden people actually trusted their backups and actually went through their backups and made sure they worked. It's actually a good strategy to make everyone improve their backup strategies. And essentially what happened was they just shifted their focus a little bit to something that was easier. So coin mining malware. So what it essentially does is when you open a website, etc., on your computer, it would just load up the CPU or the graphics card on your device and do coin mining, and they would only get a tiny bit of your processing power, but it would all contribute to them making a lot of money on the back end. And they would mine crypto coins. Usually Monero was the most famous one, or one called XMR. XMR. But there were some really interesting examples in this coin mining phase, and it's actually dying off now, that you had a virtual security problem that turned into physical consequences. So there's some old computers in some factories and things covered in dust. All of a sudden they go to 100% CPU. Some of them caught on fire, burn the whole building down. So you get this weird virtual to physical sort of consequence that happens. But coin mining itself is super easy. Don't get scared. I'm going to show you a picture of the dark web. This is it. It's exactly what you would think it is, right? There's like Russian writing, there's weird Japanese manga, stuff like that. But the point here is that these guys are selling a coin miner with an admin panel, with all different like levels of support, things like that. You can just go and purchase this, right? This is SaaS, right here, right? You want the bronze, the silver, the gold, the platinum, right? You can just buy exploits. And you're not just buying an exploit that you have to code and craft. You're actually buying like a web portal that you can log into. You can manage all the devices that you've exploited. You can kick off new ransomware demands. There's all these things you can do. Like literally think of it like AWS or Azure for hackers. And this is really common. I'll show you why cryptocurrency was so, cryptojacking, was so like popular. Because that's all the code it would take. That's all I have to do. On a web page, all I do is inject this into the web page, and I'm making money. And your computer's at 100% CPU with no prompts, nothing like that. So as long as you kept that web page open, this would keep running. Now, this CoinHub company was actually a legitimate company. They're going out of business. I think they just announced that they're like shutting down recently.
Oh, what about them?
It was legitimate. Like they weren't malicious, but people just took this snippet of code and were like, I think I can work out ways to make money with this. And of course the attackers like would load it into a web page, make it persistent. And what they would do is, one of them had a cool way where they would load the web page and then they would instantly minimize it straight behind the clock on Windows, just under the taskbar. So unless you hid your taskbar, you couldn't find the actual page itself. And it was a tiny little square of like 10 pixels. You could find it in Task Manager, etc., and shut it down. But that was just the beginning. Like, you know, they obviously worked out many, many ways to exploit this and be innovative in how they would deliver it to you. And it was successful. Some people here have probably been to this website. It doesn't exist anymore. Almost. I go there to download Linux ISOs quite often. But essentially, this is coin mining in action. It just looks like a normal web page. But you can see there's some HTTPS connections. You can see the CPUs are 100%. But it was interesting to watch the attackers here and how they would scale. So there's some numbers there on that left-hand side, right-hand side, sorry, showing you sort of how they would scale. And literally in a week and a half, these guys stood up this many hosts. And the point being is that the attackers are not the only ones. You know, we're not the only ones using cloud scale. Attackers use it too. So this is a Maltigo report. So this little dot here, that's one IP address. And all the blue dots are all the unique domain names associated with that one IP address. So they would stand up a host, and then you can see all these weird URLs. But this is how they would try to phish you. So if you have thousands of employees, they would just build thousands of URLs, just like an old school mail merge. Everyone gets a unique URL. And even to the point where everyone gets a unique piece of malware. Right? So the payload, the actual Windows executable, is also unique. So whatever your defense technology is, has to look at every piece, and it doesn't have a verdict already. It doesn't have a hash for that file. It has to go through the same process of diagnosing whether this is good, bad, unknown, whatever it is. And to show you how much these guys make, this is just October 2017, November. I need to put some more figures on here, but this is millions. There was a point where this particular piece of malware was making about $1 million a day because they had that many hosts that were just incrementally adding a little bit of CPU power to do this coin mining. I already talked about that. So now mostly attacks are very polymorphic, right? Everything is unique. And this is an interesting slide. Oh, it got broken somehow. Let me skip to the next one. This is from the Verizon Data Breach and Incident Report. I love this slide because it's basically showing you, if you look down here actually, so this is a time scale, seconds, minutes, hours, days, weeks, months, years. Right? So the time to be compromised, you can see, is usually minutes. Right? It's never out here, although with social media it's sometimes way out here because there's just such a long, sort of runway where they lead into it. The time to discover that you've been breached, the time for data to be exfiltrated is usually minutes, very closely aligned to the compromised time. Sometimes hours, days, sometimes weeks. Usually this is because they've exfiltrated very quickly what they can get their hands on, and then they just take some time to leverage their access through the network, move laterally, find other high-profile targets within your network, and exfiltrate data. So the time to contain a threat, minutes, hours, days, weeks, months, right? It's usually months before you can contain a threat. And some of the really high-profile hacks like Sony and Target and things like that, it's like 18 months until they found out that they'd been breached. And then the time to contain, you can see, is usually quite long as well. Sometimes it's really fast because your defenses stop that happening. But you can see there's a huge disconnect here between how quickly you can be compromised, how quickly data can be exfiltrated, and then how quickly we're actually discovering and containing that. So what's the solution? We're back to this, all right? Or this. There are things you can do, so I don't want to be all doom and gloom.
So back to that other one. Who has a watering can in their data center?
Hey, this is my house.
Oh, okay. I want to move that.
It's full of deer.
Yeah,
Yeah.
pour water.
It should say, in case of cyber attack, pour water on this. So let's talk about something you can do now to help out and improve your security. So this is a slide I love from Gartner. It's called the Adaptive Security Architecture. Right? And I think what we've all done, all those products that I show in that huge slide deck with the best of breed, the silver bullets that are all in my network, essentially they're really focused on prevention and detection. All right? Everyone's throwing millions of dollars at those two categories. Prediction, there's a little bit more of that going on. I guess you call that that's where AI is, machine learning. Unfortunately, the trend to do things like set mousetraps in your networks and run deception networks and honeypots and stuff like that has died off in popularity. The products aren't really there. Certainly people roll their own, but that's an area that you could put some effort into, and I like the mousetrap idea, right, in a network. If someone's touching something in my network that's purely a mousetrap or a honeypot, there's got to be reasons that's happening. And I'm not worried about the things that all the firewall and the antivirus and everything can detect. I'm worried about the stuff that's flying under the radar. Right, and the only way I can find those is using things like deception networks. But the area I think there's some real benefit is in response. Right, and the way I like to think of this is how your security team operates, it's not in alignment with how the attackers operate. Right, your security team probably has to sit down, get incidents and alerts on their dashboard or their email, whatever it is, have a meeting about it, talk about solutions to solve the problem, take it to a change board to get approval, wait for the maintenance window to implement those changes, etc. Right, this is a long, drawn-out process. I don't picture a guy in Romania who comes back from lunch, he has his coffee, he sits down at his computer, he has a couple of screens, he's got a portal that shows all the different machines that have been hacked while he was on lunch. And I don't think he's waiting to have a meeting to press a button that says, I want to ransom all these people. Right? It's all just automated already. So I guess where you can really help yourselves out is in response and using automation to make a response really, really fast. So here's a few examples here. So if you're going to manually basically investigate a piece of malware that's come in, and these are really best case scenarios, you get some alerts, you look at the computer and do things like that. It's going to take you 2 to 3 hours, essentially. And I used to work at a company that ran sandboxes. That was all they did. And they would do about 92% of all malware could be classified automated using AI, using all sorts of static and dynamic analysis. But about 8% of all files had to actually go to what we would call a manual verdict, where a human would have to reverse engineer it. And it would take about 3 hours to reverse engineer the actual malware payload. But if you look at automation in network security, you can basically pull this time window down to 10 minutes, under 10 minutes, sometimes under 60 seconds. So if you think back to that graph of how long it takes to be exploited and for data to get exfiltrated, if you can get down to, say, the 10-minute and under category to respond to threats, then you're sort of in alignment with the people that are attacking you, which is good. Like, honestly, I want to be more to the left of my attackers, but if I can at least be responding as quickly, then that's of interest to me. So how do we get there? So essentially, you might have a little bit of automation in your network right now. Some of you guys might have personally automated something in your network. Right? It's usually someone that wants to make their day job easier. You just write a script that does something or responds to something that happens on the network because you want to speed things up and go do something that's actually more interesting, usually. There's a little bit of what we'd call event-driven automation in networks today. So Juniper is one of the companies, there's a few others, where we can take events that are happening and then apply automation based on those events. And where I would like to end up is doing something like machine-driven automation, where essentially we have automated systems that use AI and machine learning to make most of the decisions on my network, to implement defensive mechanisms, and it's only a human needs to get involved when the machines can't really work out what's happening. So where do you think attackers sit on this scale? Yeah, someone said N. I reckon they're pretty close. Right? All the malware I can think of can run autonomously, changes its behavior based on the network it runs in, checks what operating system, tries to determine if it's sitting in a sandbox, infects machines all around it, tries to spread laterally, might use command and control, might just work without command and control. These guys are really automated compared to most defenders. Most defenders are looking at their portal, getting their email alerts. You've got event fatigue from your SIM just sending you thousands of alerts. Most people aren't over here. So what you can do is implement something like this. And I just called it evolved architecture. Juniper has a different name for it, but I'm trying to keep this non-vendor specific. So essentially all you have in a network like this is you have detection, you have policy mechanisms, you have enforcement, and these just happen across the network. So essentially if we look at the detection layers, you have things like physical firewalls, everyone has one. You have virtual firewalls, whether it's a VMware, whether it's actually running in the cloud, for instance. You have your virtual firewalls, and Juniper makes a container-based firewall running in Docker, which is pretty cool as well. But these are your detection elements where you can tell if something bad is happening on the network. A user's tried to download a file, someone's clicked on a phishing email, whatever it is. And your enforcement layer can be your physical firewalls, which is very typical. It's usually your perimeter firewall. But why can't it also be your switches? Right? I would prefer to do enforcement all the way down to the switch port layer and take it as close to the source of attack as I can. And I want to push in both directions. I want my enforcement to be at the perimeter, as close to the attacker as it can be, but also as close to the endpoint that's being compromised, essentially. Policy, in our case, is just driven by something called security director and policy enforcer. It's just for visibility. It's for pushing policies to devices. And detection, of course, we have these cloud-based things, sandboxes, antivirus, static, dynamic analysis, stuff like that. Let me give you an example. So this particular user just reaches out to the internet. They've clicked on a link. They got the Ray-Bans advertisement, whatever it is. They clicked on their email. And they reached out and they've just pulled down a file that we know is bad. Right? And we know it's bad because it went through the sandbox, or it got triggered by antivirus, or maybe we've got a new update that tells us that file's bad, or it could just be that they're reaching out to a known command and control server. So we keep huge lists of all the known command and control servers. If something reaches out to it, we can say, hey, that host is infected. Sort of like the mousetrap analogy. So when that user reaches out, what we'd normally do in any network is put a block at the perimeter. right? So you put a policy on your firewall that says, hey, I'm blocking that device. But the problem is that this device, depending on how your network's configured, can still talk to everyone else in that layer 2 network. Right? And in some networks, that's every single device in the entire company. Sometimes people VLAN their printers. That's about it. But you can basically infect all the servers, all the other people on the Wi-Fi, everyone else. So what we do instead is when we do this automated response and say, hey, I want to add this 225 user into my infected host feed, I'm going to send this policy to my firewall, but I'm also going to push it down to my switch layer. And this is all automated. There's actually options. It could happen in seconds because we're saying, I want this fully automated. And my posture is if someone reaches out to a known command and control, I'm going to consider them as totally compromised, and I'm either going to move them into a VLAN where they're blocked from accessing internal resources, or I'm just going to totally block them from the network, sort of like old school 802.1x. So we apply that policy at the switch layer, at the firewall, and even you can think about having like Wi-Fi controllers in there as well. All right, so this is just a way to do automated response and be at the same speed that the attackers are basically attacking you and compromising you. And that's it. That was all the product stuff. So essentially to move forward, manual workflows are not where you're at to try to be an effective defender, to try to be a flawless defender. Whatever you do, try to automate something in your network to make your response faster and faster. Buying more hardware or more products is also not the answer. You just incrementally improve, like your 99.1 is going to be 99.2%, but tomorrow it's going to be 88, next day it's going to be 100, etc. I already showed you that slide. And then every single device in your network should be participating in your security. You already spent money on it. It's already sitting there. It's probably ingesting data. It can give you visibility into the network, etc. But you should be using all the devices to do your security and stop attacks earlier in the kill chain and respond at the same speed the attackers are. Now, if you want more data on this, you've got to come and see Lee or Doug and have a beer with him later tonight. That's it from me.